Welcome to the last section, to the last lecture of intermediate algebra. So today is going to be the last thing. This will be the last topic that we are going to look at. Two different things that we are going to cover. It will be a little bit on the shorter side. First, we are going to multiply radical expressions that have more than one term. What we are going to do here is the square roots of 6, and we want to multiply it with x plus the square roots of 10. And what we are just going to use, we are using our distributive property. We are going to say, all right, I open up the parentheses. This is the square roots of 6 times x plus the square roots of 6 times the square roots of 10. And what I will get out of this here is, well, the square roots of 6 times x, there is nothing that I can do, but writing it the other way around, this looks a slight little bit better. For this reason, a lot of times we are getting sloppy when we are writing down radicals. And if I write it like this, then you notice then I might get confused whether this x is supposed to be underneath the radical or if it is supposed to be on the outside. This is a reason also why I am always closing my radical sign. But it's even easier if we just put the x in front. Now, the second one, the square roots of 6 times the square roots of 10, that I can work with. That will be the square roots of 6 times 10 is 60. And now I will look at the number 60, and I have to see whether or not there is a perfect square in it, and I see already one. 60 is the same thing as 4 times 15. And that makes the square root of 60 the same thing as the square roots of 4 times the square roots of 15. And of course the square roots of 4, that is just 2. So we will always simplify if there is something that I can simplify when we multiply these things out. Let's do something that has 2 terms in both. So in other words, these are kind of like binomials. And what we are using, we are going to use our FOIL method. We are foiling this out. In other words, the product of the first, the product of the last, the product of the inner, and the product of, well, what did I say? The product of the first, the product of the outer, the product of the inner, and the product of the last. Excuse me. So, what do we have? We have the square roots of x times the square roots of x. This is the product of the first. Plus the square roots of x times negative 3. This is the product of the outer. Plus 2 times the square roots of x. Plus 2 times a negative 3. And if I look at all of this and I simplify this, then I get the square roots of x times the square roots of x. Let's write this in between step. This will be the square roots of x squared. Square roots of x times a negative 3 is the same thing as a negative 3 times the square roots of x, plus 2 times the square roots of x, minus 6. And you see the same thing happens when we multiplied out our binomials. The outer and the inner product can be combined because they are like terms. In this case, like radical terms. The square root of x squared, strictly speaking, it's the absolute value of x, but we are just considering positive values, so I can just write x. Negative 3 square roots of x plus 2 square roots of x, I'm left with negative 1 square roots of x. And that is it. Nothing else to be done. I have multiplied these two expressions out. So here is the very last thing that we want to look at, and this is called rationalizing the denominator. Rationalizing the denominator means that I have a rational number in the denominator. The square roots of 7 is not a is not a rational number, it is irrational. There are no two nice numbers multiplying together giving you 7. So what I remind myself of is that the square roots of some number multiplied by the square roots of some number is just this number itself. If I would go the in-between step and I would say this is the square roots of a squared, this is just going to be a if I am talking about positive numbers a. So what I will do right here is this. I will multiply this with the square roots of 7 divided by itself. Why can I do this? Because this right here is nothing else but the number 1. Just like 3 divided by 3 or 4 divided by 4 is 1, the square roots of 7 divided by the square roots of 7 is also 1. So in other words, I don't change anything. Anything multiplied by 1 is just the number itself. And now I just multiply straight across. In the top I get 3 times the square roots of 7. And in the bottom I get the square roots of 7 times the square roots of 7. That will be just 7. The square roots of 7 times the square roots of 7, that is the square roots of 49, which is just 7. And I'm done. So when we have more than one term in the denominator and there's a radical involved, then we are going to do the following. I remind myself of this fact right here. We called this the difference of two squares. A plus b times a minus b is a squared minus b squared. The product of the outer and inner term would cancel out. In the same way, I have that the square root of a plus the square roots of b times the square roots of a minus the square roots of b would be the square roots of a squared minus the square roots of b squared. And this right here is just a, and this right here is just b. These are called conjugants. So the conjugant of something plus is something minus, and vice versa. So maybe just we'll practice this. What is the conjugant of 2 minus the square roots of 3? Well, the conjugant of 2 minus the square roots of 3 would be 2 plus the square roots of 3. Vice versa, the conjugant of 2 plus the square roots of 3 is 2 minus the square roots of 3. And how am I using this in this case again? I am multiplying this again by a factor of 1. But this factor needs to be chosen wisely. I'm using the conjugant of the denominator. And the conjugant of the square roots of 3 plus 2 is the square roots of 3 minus 2. Just like in the last example, this is nothing else but the number 1. You have to make sure that this is the same thing divided by the same thing. And what I'm doing right now, I just multiply this out. On the top, I get 18 times the square roots of 3 minus 2. Don't open up those parentheses quite yet. In the bottom, I get, let's be careful, this is the square roots of 3 squared minus 2 squared. So what this will be now, let me move this here a little bit to the side so that we have more space. I have 18 times the square roots of 3 minus 2 divided by, let's have a look, the square roots of 3 squared is just 3. Minus 2 squared is 4. So 3 minus 4, that will be a negative 1. Three minus 4 is a negative 1. So I can just take this negative 1 and I can put it in the top. This is a negative 18 times the square roots of 3 minus 2. And you should be able to enter your answer into the homework assignment just like this. Or if you want to multiply this out, you could do this as well. This will be a negative 18 times the square roots of 3. A negative 18 times a negative 2 would be a positive. Let's have a look. That would be 20 plus 16. That would be 36. Or I could even write it in this way. 36 minus 18 times the square roots of 3. All of these are the same answer, and it should count it as right in the homework. If you have any questions about this, please send me an email. And this was the end. I hope that you guys enjoyed the class. I was trying my best to make the things as easy as I can. If you have any questions, please let me know. I hope to see you all in college algebra.